Hello my dear students, this is Akash HD and welcome to the ASD physics classes. Hope so doing really great. So students, in this class we are going to learn about the binding energy concept, and after that we will see the application of binding energy, that means the escape speed. And at the end of the video we are going to learn that escape speed from the earth surface is how much? 11.2 kilometer per second. And if the planet is changing, then how the escape speed will change? Very interesting topic. Let's learn this topic, students. So before starting this, we have to understand some basics. Okay, even this basics I have discussed in a last video also. So see here, please here. First one, mechanical energy is the sum of kinetic energy and potential energy. And after that, next one, very important point, at infinite distance away from planet, that means where in interstellar space, potential energy of the projected body will be how much? 0, because object will go outside the gravitational field of the planet, so there is the no interaction. That situation, potential energy how much? 0. Okay. Next one, students, in interstellar space, minimum kinetic energy of the projected body will be 0. Why I am telling minimum kinetic energy? Because we are going to learn, if we are going to throw the object with the escape speed, then in interstellar space the kinetic energy is 0. But if we throw more than the escape speed, we can throw more than escape speed also. Like I told, 11.2 km per second, we can throw with more than 11.2 km per second also. In that situation, what will happen? The kinetic energy will be more than 0. That's why here we have written minimum kinetic energy 0, so that we can calculate the escape speed value exactly. Next one, students, fourth point, in interstellar space, minimum mechanical energy of the projected body will be 0, because kinetic energy is the minimum, so mechanical energy will be also minimum. Why? Because mechanical energy is the sum of kinetic energy and the potential energy. Okay. After that, now we are going to enter into our basic topic, the binding energy, or we can tell escape energy also. So see here, please, the minimum energy required to send a particle infinite away from the surface of a planet is called binding energy of planet particle system. Underline the word, this minimum energy we have to give. Okay. After that, next one, students, this is our point, binding energy of a particle on the surface of earth. Okay. So see here, please here, let a particle of mass small m is placed on the surface of earth. As shown in diagram, mechanical energy of the particle is given by. So students, here I have drawn here one planet. Okay, one planet is there. Its radius how much here? R. And mass how much here? M. Now what is there? One small object, one particle, small m, we placed at the surface of the planet. So what is happening? When the object is at the surface of the planet, we can tell total mass of the planet, we can concentrate at the center, and this is the small m, and this distance how much you know very well? R. So in this situation, students, the potential energy will be given by what? Minus g mm by r, and kinetic energy how much? 0. Okay, that means the mechanical energy is given by u plus k, and u what I told? Minus g mm by r plus kinetic energy 0, as we are doing for the earth now, and earth is solid, so like this will draw here now. So this is my water, this is my energy. Which energy? Positive or negative? Negative energy. Because of this negative energy only the object is bound to the planet. If anyhow this energy is becoming 0, that means if we add plus g mm by r in this, then what will happen? The object will go into the interstellar space, that we are going to learn through the language form. See please, due to this negative mechanical energy of the particle, this is bound to the earth, as I told you. Now, to make the particle's energy 0, that is to send the particle in interstellar space, binding energy of the particle how much? As I told you, students, this binding energy will be what? The negative of the mechanical energy, and this will come how much? Plus g mm by r. What is this? This is the binding energy. Okay, again I am telling you by with the very basic. So see here, please here, the mass m is there, and this is capital M, and this is the radius r. So let's take for example here this energy how much? For example, minus 50 joule, is it? And you know very well in interstellar space how much energy is there? Minimum 0. So how much energy we have to give extra to this so that its energy will become 0? How much energy we have to give? We have to give plus 50 joules so that energy will become how much? 0. And this 50 joule energy is called which energy? This 50 joule energy is only called binding energy, students. Here, so this is the basic. And again, let me draw here like this. Now after the students, next one please. Escape speed. If binding energy is supplied to the particle in form of kinetic energy, then it will leave the gravitational field of the earth. Yeah, correct. Now, therefore, the minimum speed with which the particle must be projected upwards in order that it may just escape from the gravitational field of earth is called what? This is called the escape speed. Anyhow, this binding energy we have to give to the particle on the surface of earth. In different ways we can give, but here what we are doing, we are giving in the form of kinetic energy. Okay, so here please, here the kinetic energy supplied to particle is equal to what? Binding energy. Okay students, so here please, here again, here I have drawn here. Now earth is there like this, earth, and here this is there, m. And what we are going to do, we are going to project it with some speed. Which speed we are going to throw? With the escape speed. Now, so let's take here, this is the interstellar space, now like this. So here what will happen that here, as I told you, u infinity 0 and k infinity minimum, what I told you, 0, and energy infinity minimum, how much? 0. Is it? So now as we have learned that kinetic energy supplied to a particle is equal to what? Binding energy. So how much kinetic energy formula, students, here at this point? We can write here the kinetic energy is given by half m VE square. Binding energy is how much? G m by r. So what will happen that, students? Both the sides, this small m and small f cancel out. Very important. And from that only we are going to learn this escape speed will be independent of the mass of the projected body. So from here, when you will simplify this escape speed will come how much here? Root 2 gm by r. Okay, if this is the earth means you can write re also, no problem here, no problem. Now this is the escape speed. You know very well mass of the earth, radius of the earth, g value and all that. So when you will put all this value, it will come how much here? 11.2 kilometer per second. After that, students, we have to remember some other forms also. Like you know very well, I have taught you g equal to gm by r square. So from this escape speed we can write here, just put the value here. So it will come here root 2gr. Now I have just put the value of gm gr square, then rr will cancel out. After the students, next one, you know very well in terms of density, g equal to 4 by 3 pi rho gr. If you write in terms of the density also, so just put the value here. V equal to root 2gr is there now. So what will happen that here? Just put the value of g. So what this will become here? Students, 2 and g value how much here? 4 by 3 pi rho gr and into r. Okay, students, so it will become here what? 8 by 3 pi rho g r square. Now, so we have to remember the formula in terms of mass, in terms of the gravity, and even in terms of density also. Anything can be used in a exam. Next one is, students, some important points are there. We have to just remember that. What is the first point? See please, it depends on the mass and radius of the planet, capital M and capital R. Next one is, students, it does not depend upon the mass of the projected body, because we have seen that small m both the sides cancelled. Third one is, students, it depends on the location from where the particle is projected. Why? Because small g value changes place to place. So escape speed will also change place to place. Fourth one, it does not depend upon the angle of projection. That means if this is the planet, you can throw in any direction. Maybe you can throw in this direction, you can throw in this direction, you can throw in this direction. That's why we are using the word escape speed. Okay. Last one is, students, for Earth to become black hole, very important concept. The escape speed from the Earth must be equal to the speed of the light. That means what I'm telling that here, this VE should be equal to C, then only the Earth will become like a black hole.